Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video introduces the idea of simulations and then explains the law of large numbers. Let's get started. So most people, when they hear the word simulation, they're thinking about some computer-generated environment. And certainly that is a simulation. But when we're talking about statistics and particularly about calculating probabilities, all we mean by the word simulation is a procedure where we actually, engage a process that behaves the same ways as the procedure itself. So in other words, we're trying to calculate all the different possible combinations in the sample space. And that's all simulation is. We're just calculating the sample space. So simulations, we actually do this because they allow us to see the results of a procedure without incurring the actual expense of performing the procedure. So, in the previous mini video, where we're talking about like births of newborn children, so, we don't have to actually go through the births to see what the sample space is. We can just simulate it in our minds, go through the process in our head to figure out, okay, these are the possible sample combinations for 3 births. Now, simulations are only as good as the underlying assumptions and boundary conditions that you use to create them. But, like I said, you don't need, this computer-generated environment to have a simulation. You can actually, just perform in your head. And we've done that already, okay? So, going back to the birth example, where we're looking at 3 births, what are the possible sample combinations? We could actually run through that in our heads without actually going through the physical process of birthing 3 children in order to see what the possible sample combinations are. And that's all we mean when we say simulation. So we can get our sample space, and then we can calculate the probability of whatever event that we want to occur by looking at the sample space and counting it up. Now, computers can be used to get simulations for calculating probabilities, and usually you're going to result to a computer if you're looking at something that's a very large sample space. For something that's relatively small, like what we see here with the birth of 3 children, and looking at the possible genders, 8 is a rather small sample size, and so it's okay for us to take out pencil and paper or just do it in our head and perform the simulation that way. But for the larger sample sizes, you're going to need, something like a computer to help you calculate everything out. This brings us to the law of large numbers, because as you take this procedure that you're simulating and you repeat it again and again and again, what you find is that the relative frequency probability of an event tends to approach the actual probability. So to illustrate what we're talking about here, let's use a simulation where we're flipping a coin to test this law. And we're going to assume that the coin is fair. So you have just as much chance of getting heads as you get tails. So the probability of getting heads from a coin flip is going to be 50% because it's a fair coin. What we're going to do now is calculate the observed probability of increasing number of coin tosses to see if it approaches 50%. And to do this, I'm going to use a simulation feature that you can find in StatCrunch. So using that simulation feature, I'm going to say, I'm going to toss a coin 10 times, and here's the results. I did that, and the simulations told me that 8 of the 10 tosses came up to be heads. So that gives me a percentage of 80%. If I put 10 more tosses into the mix, now I've got 14 of the 20 come up to be heads. And then if I do the 30 tosses, I get 15 to be heads. So if I calculate this all out and put it in a table, here's what you'll find. So for the first run where I did 10 tosses, I got 8 heads, and that gives me 80% of what I actually got out were heads. If I did it 10 more times and then add it to what I had before, that gives me 14 out of 20, which is 70%. And then 10 more times, I get 15 out of 30 are heads, and that gives me 50%. So we can see that as we continue to toss our coins more and more, the percentage that comes out to be heads actually approaches what we would theoretically calculate, what we would expect to see from our coin toss, which would be 50% are going to be heads. And this is the law of large numbers, that the more we perform that procedure in our simulation, the more we actually get what we would get in the real world, what we would expect to find. And that's all that the law of large numbers is. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.